Hey guys, it's Leia. Today we'll talk about solving inequalities with two absolute values. In order to solve these inequalities, first set each expression in the absolute value equal to 0 and solve for x. Next, write ranges where we will evaluate the inequality at. The ranges are x is less than a is less than or equal to x, which is less than b, and x is greater than or equal to b. A and B are the solutions we get from step 1, where A is less than B. Next, we test each absolute value for its positive and negative range. Next, we evaluate the inequality at each range from step 2. We will use the negative and positive ranges from step 3 to determine if we plug in the negative or positive value of the absolute value into the inequality. Finally, combine the ranges. Make sure to check and see if each inequality holds. Now let's see two examples. First example, we have the absolute value of x plus 1 is less than or equal to the absolute value of 2x. First, we set each absolute value in the expression equal to 0 and solve. We set x plus 1 equal to 0, and we get x equals negative 1. Then we set 2x equal to 0 and get x equals 0. Next, we write the ranges using this identity. We see that a equals negative 1 and b equals 0 since a is less than b. So our ranges are x is less than negative 1 is less than or equal to x, which is less than 0, and x is greater than or equal to 0. Next, we test each absolute value for its positive and negative range. First, we will test the absolute value of x plus 1. We will see when it's positive first. So we set x plus 1 greater than or equal to 0, and we get x is greater than or equal to negative 1. Now we will check when it is negative. We set x plus 1 less than 0, and get x is less than negative 1. Now we check the positive and negative ranges for 2x. We check its positive range first, so we set 2x greater than or equal to 0 and get x is greater than or equal to 0. Next, we find its negative range, so we set 2x less than 0 and we get x is less than 0. Next, we evaluate the inequality for each range. Here's a table to show when the absolute values are negative and positive to help us with this step. Here are our ranges which we will evaluate the inequality. First, we will evaluate at x is less than negative 1. We take a look at our chart to see what to replace the absolute values with. In this range, both x plus 1 and 2x are negative, so we replace the absolute values with the negative value of the expressions. Now we will plug this into the inequality. We solve and get x is less than or equal to 1. Next, we evaluate the inequality at negative 1 is less than or equal to x, which is less than 0. We check the chart to see when the absolute values are negative and positive. We replace the absolute value of x plus 1 with x plus 1, and we replace the absolute value of 2x with negative 2x. Now we plug these expressions into the inequality. We solve and get x is less than or equal to negative 1/3. Last, we evaluate at x is greater than or equal to 0. Both absolute values are positive at this range, so we use the positive expressions. We plug in these expressions into the inequality. We solve and get x is greater than or equal to 1. Finally, we combine all the ranges together. So here are all the ranges. Then we simplify and get x is less than or equal to negative 1/3, or x is greater than or equal to 1, our answer. Last example, we have the absolute value of x minus 1 over the absolute value of x plus 2 is greater than 2. First, we set each absolute value expression equal to 0 and solve. We set x minus 1 equal to 0 and get x equals 1. Then we set x plus 2 equal to 0 and get x equals negative 2. Next, we write the ranges using this identity. We have a equals negative 2 and b equals 1 since a is less than b. So our ranges are x is less than negative 2 is less than or equal to x, which is less than 1, and x is greater than or equal to 1. Next, we test each absolute value for its positive and negative range. We will test the absolute value of x minus 1 first. First, we will see where it is positive. We set x minus 1 greater than or equal to 0. We solve and get x is greater than or equal to 1. Now we find when it is negative. We set x minus 1 less than 0. We solve and get x is less than 1. Now we find the positive and negative ranges for x plus 2. We set x plus 2 greater than or equal to 0 to see when it is positive. We solve and get x is greater than or equal to negative 2. Now we see when it is negative. We set x plus 2 less than 0. We solve and get x is less than negative 2. Next, we evaluate the inequality for each range. Here is a table of the positive and negative ranges for each absolute value to help us. Here are the ranges which we will use to evaluate the inequality. First, we evaluate at x is less than negative 2. We use the table and see that both are negative in this range. We replace the absolute values with the negative value of them in the inequality. We solve and get negative 5 is less than x, which is less than negative 2. On to the next range. We look at the table to see if our absolute values are positive or negative in this range. X minus 1 is negative in this range, and x plus 2 is positive in this range. We plug in these expressions into the inequality. We solve and get negative 2 is less than x, which is less than negative 1. On to the last range. We look at the table and we can see that both expressions are positive in this range. We plug in the positive values of the expressions into the inequality. We solve and get negative 5 is less than x, which is less than negative 2. Finally, we combine the ranges. Here they are. Then we simplify and get negative 5 is less than x, which is less than negative 2, or negative 2 is less than x, which is less than negative 1, our answer. This topic can be very hard and tricky, so for more help on this topic, visit www.symbolab.com and click on the Practice tab.